Hi, welcome dear students. Today trigonometry part 9. In this also we are going to discuss different kinds of problems because we are having abundant amount of problems in trigonometry. While doing problems only we will get more knowledge and okay, in the next classes we will go and discuss about compound angles and other things like right. Let us start this problem. This first problem is like prove that 1 plus cot theta minus cosecant theta into 1 plus tan theta plus secant theta equal to 2. This is what we require to prove. How we do this part is, let us take the left hand side part. You write how we are going to do is you try to convert everything into, right, this is like something like cos theta by sin theta, right, minus 1 by sin theta, like this. Everything into cos and sines you convert like this, and this also 1 plus sin theta by cos theta, like this. 1 plus sin theta by cos theta plus 1 by cos theta, like this you take it, right. Once we have taken like this, now the okay, let us take for this particular term the LCM like this, right. If you take the LCM part for this, what we are going to get is here, this is what now sin theta, like this. Sin theta means now we will have here sin theta plus here, right, sin theta cos theta we are going to get, sin theta cos theta we are going to get, and minus 1 like this, right. Okay, sorry, this is here we are having here sin theta, therefore you are going to have cos theta minus 1, that's it, right. Sin theta plus cos theta minus 1 we are going to have, and here if you take the LCM as cos theta, like this, and here you are going to get cos theta plus sin theta, right, plus 1 you are having here like this. This is something you observe in the numerator. This is sin theta plus cos theta, this is also sin theta plus cos theta, right. Something like a minus b into a plus b terms, like this, right. Here sin theta plus cos theta minus 1, sin theta plus cos theta plus 1, something like a minus b into a plus b. That if we do that, we can get it as sin theta plus cos theta whole square, this minus 1 square. Minus 1 square is, okay, this is what, a minus b into a plus b, and in the denominator we have here sin theta into cos theta, like this, right. Now this become, what we are going to get is sin square theta a plus b whole square formula, sin square theta plus cos square theta plus 2 sin theta cos theta, right. 2 sin theta cos theta minus 1 by sin theta cos theta, like this, right. And you know that sin square theta plus cos square theta, that is nothing but 1 plus you have here 2 sin theta cos theta minus 1 by sin theta cos theta, like this, right. Sin theta cos theta, like this, plus 1 and minus 1 will cancel. 2 sin theta cos theta by sin theta cos theta, that is equal to 2, and that is what the right hand side part. How beautifully we have got this problem, you please observe, right. We simplified, we brought everything into sin and cos, and we applied here a plus b into a minus b, and simplified we have got the answer as 2, right. Now we have the next problem, the second problem. Prove that square root of 1 minus sin theta by 1 plus sin theta equal to secant theta minus tan theta if okay, theta lies from minus 90 to 90. Minus 90 to 90 means you know that, right, minus 90 degrees to 90 degrees. Whenever we are having here, this is what the graph here, right, minus 90 degrees to 90 degrees means this one, actually this is what minus 90 degrees, and this is plus 90 degrees, like this we are going to have, like this, right. Minus 90 degrees to 90, that means quadrant 4 and quadrant 1 we have here, when it lies between like Q1 and Q4, that means here Q1 and Q4, like this, right. Fine. And 90 degrees to the second one, you have to prove it as minus secant theta plus tan theta if theta lies from 90 degrees to 270 degrees, right. 90 degrees means from here to here, like this, right. 90 degrees, this is what 90 degrees to 270 degrees, that means Q2 and Q3, like this. This is when Q2 and Q3, right? My dear students, you have to remember one thing here, right? What is that is, whenever we are having the things like this, suppose this quadrant, actually this angle, this angle actually we will say that 270 degrees to 360 degrees, right? And the same way, when we taken this in this anti-clockwise direction, when you take in the clockwise direction, this only we will say that as minus 90 degrees to 0 degrees, like this. Both are same only, like minus 90 degrees to 0 degrees. These both are same only in the same way, right? This angle, right? We are going to actually, if you take like in the anti-clockwise direction, this angle is nothing but, okay, when you take this anti-clockwise direction, this angle is nothing but 180 degrees to 270 degrees, like this. But whereas when you take like this, right, when you take like this clockwise direction, when you take clockwise direction, this angle, what you can say is minus 180 degrees to minus 90 degrees, like this. Minus 180 degrees to minus 90 degrees. Like this you will be having the angles like this, right? Fine here. Okay, this is what you call the negative angle, right? Whenever you see the positive angle means when we take the angle in anti-clockwise direction, like this. This is a positive angle, right? This is a positive angle. Whereas if you take the angle in a clockwise direction, like, okay, if you take the angle like in a clockwise direction, like this, if you take here like this, for example, the angle like this, if you take here like this is clockwise direction, like clockwise, and this is negative angle, it will give you like this, okay, it will give you now negative angle. As I told you now that this 270 to 360 degrees actually fourth quadrant. The same thing we can write it as when we take in the right clockwise direction, right, minus 90 degrees to 0 degrees. In the same way here, this is 180 to 270 degrees when we take as a positive angle. Now this angle will become, minus 180 to 90 minus 90 degrees when you consider as a clockwise direction. Like this, the things we are having here like this, right, my dear students? You please understand these things. Now based on this, we are going to do this particular problem. It's a very important thing. How we will proceed, you please observe like this. Now we have here, you take the left hand side part as square root of 1 minus sine theta by 1 plus sine theta, right? This, what we do is here, right, this to do that we multiply and divide by square root of 1 minus sine theta by 1 plus sine theta we are having here. What we do is we multiply and divide by 1 minus sine theta, like this, 1 minus sine theta, right? Fine, within this, and this now it becomes 1 minus sine theta whole square divided by 1 plus sine theta into 1 minus sine theta, that is 1 minus sine square theta, that is cos square theta you are having here like this. And of course this we can write it as, my dear students, 1 minus sine theta value always the maximum value is 1, and 1 minus of sine theta will be always positive, because sine theta maximum value itself 1, it is always positive. Therefore this what we can write it as 1 minus sine theta, because it is always positive, okay. And also one more thing what we can say, this is cos theta, right, this whole square and square root for that, of course we can say that. Now this will come, I told you already in mathematics, square root of x square, like square root of x square is equal to mod x, I told you here, of course. And mod x is nothing but, you know that it is x when it is positive, greater than or equal to 0, and it is minus x when x is less than 0, like this, right? Using this fact, now what we can say is this equal to 1 minus sine theta by cos theta, like this, modulus, right? Once we got this in modulus, and what I am telling is this 1 minus sine theta is always positive. Why it is positive means sine theta maximum value itself 1, and its range is from minus 1 to 1. Therefore 1 minus sine theta will be always positive. Therefore it become like once it is positive, 1 minus sine theta you will get as it is, because mod of x become x when x is positive. That's why it become 1 minus sin theta, and divided by modulus of cos theta you are having here like this. Divided by modulus of cos theta we have here like this. Now how we are going to do this particular thing? Like now, okay, cos theta they have given that q1 and q4, like the first okay, this is equal to 1 minus sin theta by, okay, when cos theta lies in the first condition q1 and q4, in first quadrant and fourth quadrant cos theta become positive. When it is positive, what you are going to get is, this is cos theta you are going to get. That means 1 by cos theta minus sin theta by cos theta you have here like this. That means, you know, this is nothing but now secant theta minus tan theta, right? When theta belongs to q1 and q4. Very nicely we have got the first condition, like when theta belongs to, right, q1 and q4 we have got. When this is theta belongs to q1 and q4 we have got nicely this, right? Wonderful. That means first condition is true. Now the second one, okay, how we will get that, you see here my dear students. When in the second condition q2 and q3, when second quadrant and third quadrant cos theta become negative, when it is negative you are going to have modulus of cos theta become minus cos theta. This become minus 1 by cos theta, minus into minus plus, this is sin theta by cos theta you are having like this. This means you have this as minus secant theta plus tan theta for the second condition. When theta belongs to, as we told you, q2 and q3, in second and third quadrant we have got minus secant theta plus tan theta. Therefore the second thing also we have proved very nicely, right? In this way we will do these beautiful problems. These are very much helpful for competitive examinations, right? Now we have one more fabulous problem. The third one, prove that square root of 1 minus sin theta by 1 plus sin theta plus root over 1 plus sin theta by 1 minus sin theta equal to 2 by cos theta if theta belongs to first quadrant, that is from 0 degrees to 90 degrees, and it is minus 2 by cos theta when theta belongs to 90 to 180 degrees. That means it is in second quadrant, right? Let us try to do this particular problem. Let us take here we have these things, like what we do is let us take the LCM part for this, right? If we take the LCM part, this we can write like this, you see, square root of 1 minus sin theta by square root of 1 plus cos sin theta like this, right? Plus square root of 1 plus sin theta by square root of 1 minus sin theta like this, right? This is what we have in the left hand side part, right? Now for the denominator, if you take LCM, right, this become root over 1 plus sin theta into 1 minus sin theta. That is what? That means root over 1 minus sin square theta will be our LCM, right? Once we get this as the LCM, right, what we are going to get here now, root over 1 plus sin theta is there. That means root over 1 minus sin theta have to be multiplied. That means we will have root over 1 minus sin theta whole square like this, plus in the same way here you are having here root over 1 minus sin theta. That means root over 1 plus sin theta will be, you will be getting as whole square, right, like this. Now this become 1 minus sin theta. This become, you know, because 1 minus sin theta, I told you already, it is always positive. Therefore you can write it as root, okay, 1 minus sin theta in the numerator, and plus you have here 1 plus sin theta is always positive, because 1 is the maximum value, plus sin theta if you do also, it will be always positive. Therefore it is now 1 plus sin theta divided by, you have root over 1 minus sin square theta, that is nothing but root over cos square theta like this. Now this minus sin theta plus sin theta will be cancelled. Now you have here 2 by root over cos square theta, that become modulus of cos theta you have here like this. And my dear students, it is a very fact that 2 by cos theta when theta belongs to, right, q1. q1 means what? 0 to 90 degrees, right? Okay, because in first quadrant it is positive, that's why modulus of cos theta become cos theta, okay? And you have got now, okay, 2 by minus cos theta if theta belongs to Q2. Q2 means what? This one, like 90 degrees to 180 degrees. That means we have got both conditions. You see, theta belongs to Q1 means what? 0 lesser than or equal to theta lesser than or equal to pi by 2 you have here. That means here pi by 2 less than theta lesser than or equal to pi. In both conditions, beautifully this complicated problem we have got in a very easy way by taking the LCM for the denominators and simplifying the numerator. One important point you need to understand is square root of 1 minus sin theta. This is always positive, as I mentioned you, because the maximum value of sin theta itself is 1. Minimum value is minus 1. 1 minus of anything you do, it will be giving you a positive value. Therefore, that positive value will be like this, and from that you have got this simplification. You are solving the problems like this. Okay, next, fourth problem. If sin theta plus cos theta equal to x, then prove that sin power 6 theta plus cos power 6 theta equal to 4 minus 3 times of x square minus 1 whole square whole by 4. This is what, okay, we have to prove. It's a very important problem. How we are going to proceed, you please observe, my dear students. They given that sin theta plus cos theta equal to x, right? If sin theta plus cos theta equal to x, now squaring on both sides. If you do squaring on both sides, what we get, right? This you know that sin theta plus cos theta whole square, okay, that squaring on both sides, this is will be x square like this. Now this become sin square theta plus cos square theta plus 2 sin theta cos theta like this. 2 sin theta cos theta is equal to x square like this, right? And this become, now you see, sin square theta plus cos square theta is 1, and we have got, my dear students, here 2 sin theta cos theta is equal to x square from this. Now from this 2 sin theta cos theta is equal to x square minus 1, and from this sin theta cos theta is equal to x square minus 1 by 2 like this, right? Sin theta cos theta equal to x square minus 1 by 2. You have got this fact like this, and we want to get sin power 6 theta plus cos power 6 theta, right? This we can write it as sin square theta whole cube plus cos square theta whole cube like this, right? Sin square theta whole cube plus cos square theta whole cube. As I already told you that a cube plus b cube formula, you can write it as a plus b whole cube minus 3ab into a plus b. Let us use this fact, right? A cube plus b cube equal to this one. Now from this you see what we will be getting it as sin power 6 theta plus cos power 6 theta a plus b. A plus b means sin square theta plus cos square theta whole cube, right? Minus, right, 3ab, 3 into sin square theta cos square theta into a plus b, right? 3 into sin square theta cos square theta into, we have here, like here I am writing here, okay, sin square theta plus cos square theta, right? Once we have got this one, this you see, my dear students, 1 cube, sin square theta plus cos square theta is 1 cube. 1 cube is 1 minus 3 into sin square theta cos square theta. You have got into sin square theta plus cos square theta become 1. Now we have got on whole this one, 1 minus 3 sin square theta cos square theta, right? And we know that, right, sin theta cos theta as x square minus 1 by 2. We know sin theta cos theta as x square minus 1 by 2. Let us use this fact and we substitute here, right? You see, now we have got, the thing, total thing as sin power 6 theta plus cos power 6 theta. We have got as 1 minus 3 sin square theta cos square theta, right? Let us put this 1 minus 3 into sin theta cos theta, we know x square minus 1 by 2. This is now x square minus 1 by 2 whole square. We can write like this, right? And of course, if we simplify this now, let us simplify this now. 1 minus 3 into, this is x square minus 1 whole square by 4. And if you take the LCM here, this is now 4 minus 3 into x square minus 1 whole square like this. 4 minus 3 into This is what you require to prove the right hand side part, my dear students. How beautifully it is got simplified and brought into the right hand side part very nicely, right? You please observe. Okay, the next we have a very important problem, the fifth one. They given that if sine theta plus sine square theta equal to 1, then find the value of cos power 12 theta plus 3 into cos power 10 theta plus 3 into cos power 8 theta plus cos power 6 theta minus 1. Such a big trigonometric expression value we have to find using the given condition. Sine theta plus sine square theta is equal to 1. How we are going to achieve this particular problem? You see, my dear students, they given that here, right? They given sine theta plus sine square theta, sine theta plus sine square theta is equal to 1, right? From this, sine theta is equal to 1 minus sine square theta, right? That means that equal to cos square theta. That means we have got a wonderful thing. Cos square theta is equal to sine theta. We have got a wonderful substitution, like sine theta is equal to cos square theta we have got here. Like, now what I do is we need to find the value of this. What I do is here from this given thing, what we do is I will take common. Cos power 6 theta is common. Cos power 6 theta I will take common in the, okay, from this we will take cos power 6 theta. Once you take cos power 6 theta, this become cos power 6 theta plus 3 into cos power 1, okay, 4 theta you will have, plus 3 into cos square theta you will have, plus 1 you will be having like this, and minus 1 like this, right? This will be like this, right? Wonderful. That means we have got this, right? You can write it as cos power 6 theta into this. Of course, my dear students, you can write this as very nicely cos square theta plus 1 whole cube you can write, because you know a plus b whole cube, a cube plus 3a square b. A cube means cos power 6 theta plus 3a square b, 3 into cos power 4 theta into 1, 3ab square, 3 into cos square theta into 1 plus b cube means 1. Wonderfully we have got like this, and it is minus 1 like this. Okay, wonderful. Now we know that cos square theta is equal to sine theta. Now this I can write it as cos square theta, means this is cos square theta whole cube I can write, and this is cos square theta, you know, this is now sine theta plus 1 whole cube, right, minus 1. How beautifully these all are getting simplifying, you please observe. And now cos square theta become what? Sine theta. Therefore this I can write it as sine theta whole cube into, you have here sine theta plus 1 whole cube like this, right? This total thing into, okay, that, and minus 1 we have here. Now because these are both cubes, if you have a cube separately, if you have a cube, b cube, you can write it as ab whole cube like this. Suppose in mathematics you have a cube, b cube, you can write it as ab whole cube like this, right? Now this one, you see, my dear students, this you can write it as sine theta into sine theta plus 1 whole cube minus 1 like this. This equal to sine square theta plus sine theta whole cube minus 1, because I just multiplied here sine theta into sine theta, sine square theta plus sine theta whole cube minus 1. That is nothing but now sine square theta plus sine theta, already they given that as 1. Now 1 cube minus 1, that means 1 minus 1, that is 0. How beautifully we got this problem, and it is got simplified to 0. The value of this is now what? 0, right? Next we have one more fabulous problem, the sixth one. How we are going to do this, you see, they given that if cos theta plus sine theta equal to root 2 cos theta, then you have to prove cos theta minus sine theta equal to root 2 sine theta, right? This is what we are going to prove. Dear students, what they have given is cos theta plus sine theta is equal to root 2 cos theta, right? Root 2 cos theta like this, right? And we want to prove cos theta minus sin theta as root 2 sin theta. We don't know. Let us take this as some k. Let us take this value as some k, right? This we take it as some k. Now let us prove that k value is nothing but root 2 sin theta, like this. Now let us prove that k value is nothing but root 2 sin theta, right? Fine. Now what we do is, for this, let us do squaring and adding first and second equation. This is now cos theta plus sin theta whole square plus cos theta minus sin theta whole square, like this. Cos theta minus sin theta whole square. Let us do squaring of the left hand side parts, and right hand side parts also we do squaring and adding, like this, plus k square, like this, right? This become now a plus b whole square plus a minus b whole square. This is nothing but 2 times of a square plus b square. That means 2 times of cos square theta plus sin square theta. You are having like this. This is equal to, you have 2 cos square theta plus k square, like this, right? Wonderful. Now this becomes 2 into 1. This is now 2 cos square theta plus sin square theta become 1. Therefore this is 2 into 2. Okay, 2 is equal to 2 cos square theta, right, plus k square. You have like this, right? And from this it is very fact that k square equal to, right, 2 minus 2 cos square theta, like this. And 2 if you take common, this is now 1 minus cos square theta, and this is 2 sin square theta. You are having like this. K square equal to 2 sin square theta. From that, k equal to root 2 sin theta. Root 2, k equal to square root of that, right? K square equal to 2 sin square theta means k equal to root 2 sin theta. How beautifully we have got. That is what we require to prove. In this way you will be proving this beautiful problem, right? Now we have one of the wonderful problem. Next one is this. If cos theta plus secant theta equal to 2, then show that cos power n theta plus secant power n theta equal to 2, right? See, dear students, this problem how we do is, first where n is a natural number here, where n belongs to capital N, right? Now let us see that. Cos theta plus secant theta equal to 2, squaring on both sides. If you do squaring on both sides, like this. Now this is cos theta plus secant theta whole square is equal to 2 square. 2 square means 4. That means now cos square theta plus secant square theta plus a square plus b square plus 2ab. 2 into cos theta into secant theta. This is equal to 4 you have got. And you know that cos theta and secant theta they cancel, because secant theta equal to 1 by cos theta. Right? 1 by cos theta. That's why they will cancel. Now you have got cos square theta plus secant square theta is equal to 4 minus 2, that is 2. Now we told that cos power n theta plus secant power n theta equal to 2. Here in this case we have got cos square theta plus secant square theta equal to 2. Where n is 2 we have proved it now, right? When n is 2 we got it now, like this. Wonderful. Now we will be doing right, for n equal to 3. How we are going to get this, like we will get it now. You see, for 3. Now what we do when we have like this, what we do is cubing on both sides. Now cubing on both sides here, like this. By cubing on both sides you will have here cos theta plus secant theta whole cube equal to 2 cube. 2 cube is what? 8. You know a plus b whole cube formula here. You know a plus b whole cube formula, that is a cube plus b cube. That means this is what actually cos cube theta a cube plus b cube secant plus 3ab, right? This is what the formula. A plus b whole cube equal to a cube plus b cube plus 3ab into a plus b, like this, right? Let us use this fact. Now 3ab, 3 into cos theta into secant theta, like this, into a plus b, is that now cos theta plus secant theta is equal to 8 we have here. Now this is now cos cube theta plus secant cube theta. This is equal to 3 into cos theta secant theta. They will cancel each other. This is 3 into cos theta plus secant theta. They given it as 2. That is now 3 into 2. That equal to 8. Now from this we have got cos cube theta plus secant cube theta is equal to 8 minus 6. That is 2. Wonderfully we have got now like this. Cos cube theta plus secant cube theta equal to 2. When n equal to 3 also, when n equal to 3 also we have proved this. Like this we can proceed further, and by mathematical induction you can prove for any natural number. Okay, we can prove the result is true. N equal to 3 you proved, n equal to 2 you proved. Even you can prove this for n equal to 4 also, like this. Already we got it. Now we will do that even like you see, fine, right? We know that cos square theta plus secant square theta equal to 2 we proved. For n equal to 2 we proved. Now what we do is once again squaring on both sides here, like this. What we will get it as, okay, cos square theta plus secant square theta whole square is equal to 4, like this, right? Now this become cos power 4 theta plus secant power 4 theta plus 2 into cos square theta into secant square theta equal to 4. The cos square theta and secant square theta, they both cancel each other. Now from that, like this, cos power 4 theta plus secant power 4 theta is equal to, you have got 4 minus 2, 2. That means for n equal to 4 also you have got this result. Therefore we can apply even mathematical induction for any natural number, and you can conclude that cos power n theta plus secant power n theta equal to 2, where n belongs to capital N. Like this beautiful problem can be answered, right? Okay, thank you very much, dear students.